we want to look at some features of the multiplier in the goods market model. In the context of the goods market model, the multiplier tells us how equilibrium output changes when autonomous spending changes by 1 unit. Now, this multiplier will be in operation if any component of autonomous demand or spending changes, right? So, depending upon if government spending changes, then we'll have the government spending multiplier. If taxes change, we'll have the tax multiplier. If investment changes, then we'll have the investment multiplier. So, it will work if any autonomous component or demand changes. Depending upon which component changes, we can have the investment multiplier, government spending multiplier, or tax multiplier. Now, the multiplier works in both forward and backward direction, which means that if autonomous spending increases, then equilibrium income will increase to a multiplied extent. But if autonomous spending falls, then equilibrium income will fall to a multiplied extent as well. So it works in both ways. An increase in autonomous spending results in a multiplied increase in equilibrium income, and a fall in autonomous spending results in a multiplied fall in equilibrium income. So both directions this works. Now, something also to really pay attention is that we have some formulas, right? We know that the government spending multiplier, investment multiplier has a formula 1 by 1 minus MPC, and tax multiplier is minus MPC by 1 minus MPC. It's important to keep in mind these formulas are derived under certain assumptions, i.e., the assumptions that we're using are those in our standard goods market model, where G, I, T are taken to be exogenous. IG is equal to G bar, I is equal to I bar, and T is equal to T bar. And we're assuming a closed economy. So under these specific assumptions, we derive these formulas, right? The government spending multiplies 1 by 1 minus MPC, investment multiplies 1 by 1 minus MPC, and tax multiplies minus MPC by 1 minus MPC. If the assumptions of the standard goods market model change under which we derive these formulas can change for the multipliers. So it's not like these formulas are going to work regardless of whatever assumptions you take for the goods market model. If you were to take investment to be a function of Y, the formulas would change slightly. If you were to take taxes to be a function of Y, the formulas would change slightly. If you were to assume an open economy, there would be a change in the formulas of multiplier, right? So this formula 1 by 1 minus MPC and minus MPC by 1 minus MPC works under certain assumptions. Mainly the assumptions are that G, I, T are exogenous and you have a closed economy, I net exports are zero. If these assumptions change, the formulas can change and you would have to derive them again. So just keep this in mind. Next thing is the size of the multiplier depends upon the marginal propensity to consume. Because we know like how the multiplier process works, right? Autonomous spending changes, that changes demand, that changes income. When income changes, that changes consumption, which further changes demand, and that further changes income, which further changes consumption. So in the standard goods market model, the multiplier effect only works through C because that's a function of Y. So when you have a higher MPC, so at every round or every stage of the multiplier process, whenever income increases, so you will have a right? Consumption will increase more if the MPC is larger. So when consumption will increase more, that will increase demand more, which will increase income more, which will further increase consumption more. So finally, you'll get the final rise in in output in this case will be high when you have a larger multiplier. Because remember, the multiplier process works through changes in consumption. Because whenever in the multiplier process income changes, because consumption is a function of income, consumption is going to change. And the larger the MPC, the larger the change in consumption at each stage, which will result in again a larger change in demand, which will further change income, which will further change consumption, right? So the larger the MPC, the more consumption will rise at each stage of the multiplier process, resulting in a larger increase in output in the end. So this means in this case, so that's why a larger MPC would mean that we would have a larger multiplier, right? Because with a larger MPC, the change in equilibrium output due to 1 unit change in autonomous spending would be large. So the last feature that we want to look at is how we can use the multiplier to relate changes in equilibrium output to changes in autonomous spending. So recall the multiplier tells us how equilibrium output changes due to 1 unit change in autonomous spending. So we can say, okay, the change in equilibrium output is equal to the multiplier times change in autonomous spending, right? So for instance, if investment multiplier is 4, what does this tell us? This tells us, okay, if this tells us that equilibrium output increases by 4 units if equilibrium output increases by 4 units if investment increases by 1 unit. So if investment increases by $10 in this case, so this means change in equilibrium output is the investment multiplier times delta I, right? Because if $1 increase in investment causes equilibrium output to increase by $4, then a $10 increase in investment would cause equilibrium output to increase by 4 times $10, right? So this delta Y star is multiplier times delta autonomous spending allows us to relate changes in autonomous spending to changes in equilibrium output. Now here we knew that the investment multiplier was 4. Change in autonomous spending was 10, which in this case autonomous spending we're looking at is autonomous investment. So using this, we can say that delta y star is equal to the investment multiplier times change in autonomous investment. So it's 4 times $10 is $40. So we know, okay, when investment increases by $10, with the investment multiplier of 4, equilibrium output will increase by $40. So in this way, we can relate changes in autonomous spending to changes in equilibrium output.